Welcome to the Appalachian Heritage Woodshop, woodworking with an Appalachian flair.
This is Jerill with the Appalachian Heritage Woodshop. I've had some people ask me, what is the most difficult lesson you had to teach when you were teaching woodworking? And I would have to say that would be what I call the forces of woodworking. So I came up with a system that will help a beginner and even an intermediate woodworker comprehend the forces of woodworking. So let's look at them. There's two forces of woodworking. The first is what I call the created force. This is a force that is generated by the tool. Now, these forces apply whether it is a hand tool or a machine, and we will look at both. Today, I will use a hand plane as an example of a hand tool and show you the forces created by this tool. The other force you need to be aware of is what I call the controlling force. This is a force that the operator or woodworker applies in order to complete the woodworking task. So you have the created force and the controlling force. Now let's look at each one of these. Now I've got a piece of ash here, and I'm going to plane the edge of it, a low angle block plane, and I go to plane, and you can see it just grabs the wood and pushes the wood. So here, the amount of force generated by the tool exceeds the weight or the friction of this board on the workbench. So that means that as a woodworker, I have to secure this, or I have to apply enough force to this that will offset the force generated by the hand tool. Now there's a lot of different ways of clamping this. I'm just going to drop it in the vise, tighten the vise up, and now that vise is applying pressure to the sides of the board and making the board immobile. So as a woodworker, I am controlling the force applied with the vise to make this board immobile so that I can offset the force generated by the hand plane. So let's see now. I've got that in the vise. Now it's just a matter of planing. And as you can see, the board is not moving. So, as a woodworker, I am applying a controlled force with the vise, and I'm applying a controlled force with the hand tool, the plane. So I need to know the amount of force required. The vise is strong enough to hold it to make it immobile, and I'm strong enough to push the hand plane across the board. So that's the amount of force. I also need to know the direction of the force, and obviously it's going in the direction that I'm planing. Also, I need to be aware of the variables that can affect these forces. What are some of the variables? As an experienced woodworker, you need to be able to recognize these before you do the woodworking task and be able to control these variables. Now, a good example of a hand plane, the variables with a hand plane would be how sharp is the iron. If the iron is dull, you have to apply more force in order to get it to cut, if it will cut. The depth of cut, obviously the deeper the cut, the more force you have to apply. The angle of the iron, the less angle, the less force required to cut. And that's why you see a lot of experienced operators skew the iron, skew the hand plane just slightly, and then when they plane, it requires less force because you're changing the angle. The friction, now here's a good example. This large plane, as you can see, it has a lot of surface, so it has a lot of drag, a lot of friction. This plane is designed to be used with two hands, a tote and a handle, and because of that, I have to position my body so that I can use the force from my body in order to generate enough force to be able to hand plane. Now, I can also offset that with a little bit of wax, reduce that friction a little bit. But that's an example of some of the variables. Now, the last force is what I call the uncontrolled force. So, let's look at the outcome of an uncontrolled force. An uncontrolled force is just what the name implies. It's a force that you are not controlling. So the outcome of an uncontrolled force would be a poor quality cut. It could be a safety issue. It could damage the material or damage the tool. Now let's give you an example. If I'm planing this board and there is a knot right here, and I don't recognize that as a variable that will affect the force required, then as I go to plane, I can damage the iron in my hand plane, or I could get tear out. So the outcome of an uncontrolled force is always bad. It's always negative. It's either going to be a quality issue, it's going to be a safety issue, or it's going to damage the material or the tool. So as a woodworker, you need to be aware of any of the variables that can affect these forces. Control the variables, and then you will not have an outcome of an uncontrolled force. Now, you saw how the forces of woodworking apply to a hand tool. Now let's see how the forces of woodworking apply to a piece of machinery. I'm here at the table saw, and I'm going to simulate a rip cut, and we will walk through the process of the forces of woodworking as it applies to a rip cut on the table saw. Now the first thing I want to say is I've got the blade guard moved out of the way so that you can see what I'm talking about here, and I have the table saw de-energized so that I can actually touch the blade and move it around. Now the first thing I do is I set the depth of the blade. Now there are two schools of thoughts on the depth of the blade. The first school of thought is the depth of the blade should be high enough so that the gullets can extract the sawdust safely, but does not expose any more of the blade above the board than necessary. So that means the bottom of the gullet should be about the top of the surface when you go to cut. Let me put the board on this side. When I do that and the blade is turning, the force is this direction, back at the operator. That's the force generated by the table saw. If I raise the blade, now you can see as the blade turns, the force generated is down more than it is back. So now we know the direction of the cut generated from the table saw with the blade rotating. It will be straight back in a straight line with the blade, straight back towards the operator. Now we need to know the amount of the force generated. Many of you have experienced or seen kickback, and you know that it occurs extremely fast, and there's a lot of force to propel this board a long ways back. So the generated force is very significant. So now as an operator, when I go to rip this board, I need to apply the pressure or the force that will allow me to rip this board. So the first force I want to apply is into the blade. You never cut from the back. You never feed in this way. If you do, the minute the blade hits the board, it's going to grab it and propel it this direction and pull your hand with it. So you need to feed straight into the blade. You also need to hold the board down onto the table. If it comes off of the table, then the opportunity for the blade to grab the board is there, and give you some kickback. So you need to apply a downward pressure, and you need to apply a pressure into the blade. Now when I go to rip this, as I rip, the blade will create a gap, which is the distance of the teeth, and that's called a kerf. Once I start making that cut, if this board moves side to side, any at all, then the back of the blade or the side of the blade can grab a hold of the edge of the kerf and propel it backwards. So in order to get a straight cut, that's where the fence comes in. I have to have the fence set, and I have to have a straight edge so that that will push the board through in a straight line. So those are the three forces that as an operator I am required to generate in order to make a rip cut. So again, the three controlling forces: downward pressure, forward pressure, and pressure against the fence. Now let's look at how to do that. Many people will use a push stick. With a push stick, it is difficult to control those three forces. It is difficult to control down, straight forward, and to the side. And when you do, the board can actually move when you try to push it into the fence. So this is not the proper tool to rip cut with. You need what's called a push pad. This is an example of a push pad. You have a pad and it has a little heel, and you can apply a downward pressure, forward pressure, and sideward pressure all at the same time. This is also a push pad. This is also a push pad. Let's look at the variables that can affect the force. Now, if you remember with a hand plane, I went over those with you. With a table saw, some of the variables are the blade, the width of the blade. You have different widths, thin kerf versus a standard set, the amount of set in the teeth, how sharp the blade is, the RPM on the saw, the material is a variable, the drag or friction on the surface of your table saw is a variable. Now let's look at the outcome of some of the uncontrolled forces. And for that, I've got a piece of 9/4 live edge maple. Now if I were to rip this, as you can see, live edge, I don't have a straight edge to go against the fence, so that means I'm not able to push this in a straight line. So that's an uncontrolled force. Even if I had a straight line to put against the fence, if you notice, the board is not flat, it wobbles. So that means when I go to feed it through, it can wobble and shift, and the blade can grab the edge of the kerf and propel it backwards. So the outcome of the uncontrolled force on a table saw when doing a rip cut can be kickback, it can be damage to the blade, it can be a safety issue for the operator, or it can be damage to the material. A good example is rip cutting cherry or maple. If the wood shifts just a little bit, you can get a burn mark on the edge. That's an example of an uncontrolled force. Again, there are two forces, the created force and the controlling force. With the created force, you need to know the direction of the force and the amount of the force. With the controlling force, as an operator, you need to know the direction of the force you have to apply. You need to know the amount of force you have to apply. You need to be aware of any of the variables that can affect these forces, both the created force and the controlling force, and you need to be aware of the outcome of any of the uncontrolled forces. If you can look at these before you do any woodworking tasks, then I guarantee your woodworking will be a better quality, it will be safer, and there will be less damage to the tool or the material. So keep in mind the forces of woodworking when you're doing woodworking. This is Jerill Vance with the Appalachian Heritage Woodshop reminding you, be proud of your Appalachian heritage.